this is Mrs. Morgan, Chapter 1, Section 7, Functions. After this lesson, you should be able to determine whether a relation is a function. A relation is a function if each x has exactly one y, or for every input there is one output, or if it passes the vertical line test. We are going to determine whether each relation is a function, and we're going to explain. And the question that you want to ask yourself is, does each x have one y? Well, -7 is only paired up with 12. -4 is only paired up with -9. 2 is just paired up with 3. And 5 is just paired up with 0. So each of our x's in our domain had one y. So yes, this is a function. Here we have 2 is paired up with 1. 3 is paired up with -2. 3 is paired up with, wait a minute, 3 can't be paired with -2 and +1. So no, this is not a function. 3, this should say 2. 3 is with 1 and -2. Moving along, we're still determining if a relation is a function. Does each x have one y? Well, -2 is paired with -8. 0 is paired with 0. 2 is paired with 4. And 4 is paired with 4, which might look sketchy, but 2 has a y and 4 has a y. So yes, this is a function. Now down here, our 1 is paired with 5, 2 is paired with 6, 3 is paired with 7, and with 8, which is a problem. So no, 3 goes to 7 and 8. We are still determining if a relation is a function, and we're going to talk about the vertical line test. The vertical line test, does a vertical line cut only one place at a time? Well, I'm going to take my vertical line here and I'm going to move it across. And if I stop and look, I'm only cutting here, which is fine. If I move my vertical line more, I'm still only cutting one place at a time, which is fine. So as I move my vertical line along, I'm only cutting one place at a time, which is fine. So yes, this function passes the vertical line test. Now I'm going to come down here and everything looks fine. Yep, cutting one spot here, cutting one spot here, cutting one spot here. Oh no, we have epic failure right here because we're cutting in two places. So no, that epically fails the vertical line test. Now, before you panic, I don't think that you necessarily need to write down everything on this side. I would say that you should write down everything on this side. But we do need a problem to look at, so what do we need to do? Let's do write this. I almost want to not write this over here so that the people that are watching with the sound off copy it down, but I'll be nice. Don't write this. Just follow along. All right. So there are 3 lunches at a school. First lunch period, 352 students eat. So first one, we got 352. Second lunch period, we have 304. Third lunch period, 391. We're going to make a table showing the number of students for each of the 3 lunch periods. So making a table, we'll make it sideways. You could make it vertical if you wanted. And we will make this lunch. Oh. That looks terrible. Let's fix this. Maybe I can type it. Lunch. And we'll make this students. That looks less terrible. So we're going to have lunches here, students here, and your first lunch we had 352. Your second lunch we had 304. Your third lunch we had 391. So that is making it, wow, that one is bad. Let's erase that. Whoa. 391. So that's making a table. Domain and range. We can call this first thing, this first item your x's, the second your y's. So your domain would be 1, 2, 3. Your range would be 352, 304, and 391. The next thing we need to do is write this as ordered pairs, and forgive me, but I'm going to cheat and type it. So we'll have the ordered pair 1, 352. We will have the ordered pair 2, 304. And we will have the ordered pair 3, 391. And you might see your book use these. They're called set brackets. So these are my ordered pairs, and you kind of know what's coming. Perhaps you read it over here. We are going to graph this, and I'm going to show you how to graph it without going completely out of your mind. So you'll have an X and a Y. You see that I left a space. I'm going to come in here with my pen and kind of put a break in here that kind of shows that I'm going to skip some numbers starting at 0, because I am not going to graph all the way up to 400. That would be a little excessive. So we put this break in here so that we can skip some numbers. So instead we'll have 300 here. We'll have, let's say, 325. We'll say 350. 375, and 400. And move this over. We're going to say that these are students. Move that over, move this here. So we're going to label our student axis and our lunch axis, which is much easier. So we'll have 1, 2, 3. And this is our lunch. And we're just going to come in and graph. So our first point, that 1 and 352, approximately here. 2 and 304, approximately here. And 3 and 391, which is approximately here. All right, take a deep breath. We only got a couple more to go, and they are not terribly lengthy. Oh, they're all showing. Here we go. So if f of x, we read this f of x, and it basically functions like y. Is 3x minus 4, and g of x is x squared plus 3. We're going to find each value. So f of 4, what you're going to do is you're going to take that expression 3x minus 4, and you're going to plug in 4 for x, and you're going to calculate that down, which 3 times 4 is 12, minus 4 is 8. And g of negative 3, we're just going to put a negative 3 in for right here, and we're going to calculate that out, which negative 3 squared is 9, plus 3 is 12. And that is Chapter 1, Section 7, Functions.